In Chapter 5, we introduced you to your first chemical reaction. It was a metathesis reaction, followed this pattern. Remember, what's next? CD, whoops, and what are the products? All right. And these two compounds are what kind of compounds? These are ionic compounds dissolved in water, right? Dissolved in water. So these are aqueous solutions that are mixed together. And then one of these is either a precipitate, something like water in a neutralization acid-base reaction, or a gas. Okay? So that was what Chapter 5 was all about. Chapter 6 is about a different kind of chemical reaction called a redox reaction. A redox. Now, you can call it an oxidation-reduction reaction, a reduction-oxidation reaction. Oxidation is one thing, reduction is the other thing. However, you can't have one without the other, because oxidation means giving up electrons. But electrons cannot just go fly somewhere in the universe. They have to go around a different nucleus. And when a different nucleus gains an electron, that's called reduction. So when an atom loses an electron, that's called oxidation. And when one gains, it's called reduction. And we have a mnemonic device to help us. Have you guys heard of this oil rig before? Different chemistry class, where you're talking about oxidation is loss of electrons. Reduction is gaining electrons. Anybody heard of any others? Leo says grr. Have you guys heard of that one? Leo the lion says grr. All right. My favorite is not really a mnemonic device. It's a system that I'm pretty sure the reason why they call it reduction is if I think of an atom X. Actually, maybe it's better to use an element like copper. So there's an atom of copper. If that atom has no charge on it, see I haven't written a charge there, and maybe I'll help by putting a 0 there to help you see that there's no charge on it. What is the number of electrons and protons in that species? Number of protons and electrons? 29. We've got 29. 29 protons, 29 electrons. Okay, how about this one? Here's copper with a +1 charge. What have I done to go from copper to copper +1? The +1 makes us think we've gained an electron, but the +1 is actually just the imbalance between the protons and electrons, and that's resulting because I've lost an electron. So, copper +2, lost another electron, right? How about if I go this way? Copper -1, right? Copper -2. So if I'm here at this species, and I gain electrons as I move down, see how that works? The oxidation number here is being reduced. The value is being reduced. Can you see that? So when I gain electrons, that oxidation number is reduced, and this is called reduction. Right? Whereas the opposite then must be what? Oxidation. Okay? So seeing that number actually reducing is the easiest way for me to remember which way is reduction and which way is oxidation. All right? But we got this as well. Oil rig, oxidation is loss, reduction is gain, and we're talking about losing and gaining electrons. Now, when I have a chemical reaction like Na sodium atoms combining with chloride or chlorine atoms, and we talked about this reaction a long time ago. Why did we say that they would like to react to form a compound? Remember the sad story of sodium? What was it? That's right. And sodium just needs to do what to become like a noble gas, to have a noble gas electron configuration? Lose one electron. That's sodium's sad story. And chlorine's sad story was just needs one more. Just needs one more. All right? Now, how many protons does this sodium atom have here? 11. How many electrons? 11. Now, here, how many protons does this sodium species have? 11. How many electrons? 10, right? It's given up one of its electrons. So it's kind of like there's a positive charge on that sodium in there, right? There is no actual charge because chlorine has that electron, right? And so the charge is neutral. But chlorine, we see, had 17 electrons, and now this species has 18 electrons. So this is a redox reaction. Can you see it? One species gained an electron, one species lost an electron. All right? Who was oxidized, sodium or chlorine? Sodium was oxidized. Therefore, chlorine must have been reduced, right? And so we have another term that we want to introduce you to. It's called the oxidizing agent or the reducing agent, all right? It's the one who did the reducing agent. The one who does the oxidizing, we'll call him the what? Oxidizing agent. Now there gets to be a degree of confusion here because the oxidizing agent isn't oxidized, it oxidizes, right? And that becomes confusing to understand that, right? The reducing agent isn't reduced, but it's actually what? It's reducing, and itself is oxidized. It's oxidized. It doesn't oxidize, but it's oxidized, right? Good thing everybody speaks English pretty good, right? Craziness there, right? So we have this term called the oxidizing agent and the reducing agent, which we do need to become familiar with because there will be test questions where they just say, which one of these is the oxidizing agent? Okay? So I'll give it to you. Which one of these is the oxidizing agent? Choices are, they're, on the left side of the arrow here. Which one of these is the oxidizing agent? The chlorine is the oxidizing agent? Okay? It is. It's the oxidizing agent. How crazy is that? Why is it the oxidizing agent? Because it was reduced, or another way to think of it is because it oxidized the sodium, right? A couple of ways to think about it. All right? Oxidizing agent. That means the sodium is the what? Reducing agent. Okay, good. So then let's talk about this here. Can you identify who is acting as the oxidizing agent in this reaction? Talk to your neighbors, see if they can tell who is acting as the oxidizing agent in this reaction. Did you get it? Was it too easy for you? What's the answer? Wait, is the answer going to be anything on the right side of the arrow for this sort of a question? It's not. The question would have to be like, what is the oxidative product? Or what is the reductive product of this reaction? And that sort of thing is going to be awkward to ask. So whenever they say, what's the oxidizing agent or the reducing agent? It's always going to be on the left side of the arrow. So which one is it? Which one's the oxidizing agent? Let's see. I don't know. Oh, it was C. So close. So the oxidizing agent was the component that was reduced. Is that true? Was platinum 2+ reduced here? No? Do I have it wrong? Why is it C?
Wait, I'm confused. Because I thought it was D because the end goes from 0 to positive. Oh wait. Never.
You're not confused anymore?
Yeah. I think I got them mixed up.
Okay. So, well, what happened to zinc in this process? Was it oxidized or reduced? It was oxidized. So if I wanted to give zinc a name, what would you name it? Jeff? That's what I was thinking too. Sounds good.
Wait, actually, I'm confused again.
Well, we could name it Sally. We don't know if it's a boy or girl. I'm sorry. You're right.
Wait, why is C the oxidizing agent? Because
Why
then
is-
it's also oxidized, right?
Oh, well, let's see what happens to C. First of all, let's talk about zinc really quick. Was zinc, can we decide that, I thought we said that it was what? Oxidized? Is that what we said? Is that true? Do you agree with that or not quite? Did it gain electrons or lose electrons? It lost electrons? You sure?
I don't know, honestly.
All right. So let's look at this.
Like, I can't really see it.
Here's some element.
Yeah.
Actually, here's an element, and here's an element there. What does that plus 2 mean? Does it mean it gained 2 electrons?
It lost.
It lost 2 electrons. So I think that's the problem. We see the plus 2 and we want to say we gained 2. No, we lost 2 electrons. Don't try to remember, if it's a plus, then you lose, and if it's not, if it's a minus, you gain. Just try to think about this species here having the same number of protons and electrons. And now this species over here, we never gain or lose protons, do we? Right? Does that make sense? We never gain or lose protons. That's not chemistry. That's nuclear physics, right? And we don't teach nuclear physics on campus. So it's really far away. So we never have to worry about it. So if there's a plus 2 charge, it must be from what? The movement of electrons, not the movement of protons. So the only way you get a plus 2 charge is if there's now 2 fewer electrons than there were protons. So, lost electrons, right? Loss of electrons is loss of electrons. Oxidation is loss of, that's what it is. Oxidation is loss of electrons. All right. Do we got it? So that means that zinc was what here? Oxidized or reduced? Oxidized. Are we all confident there? And then the platinum here, it went from a plus 2 to this. What's the charge on this thing? There's no charge here, is there? It's by itself, that's it. So this is a plus 2, and now it's there, 0. Okay? Problem? What happened? What's the problem? You know what would help maybe? These here need to be subscript. Or maybe they already are subscript. Font, there we go. They're not subscript. That might be the problem. Ooh, that helps, right? I don't know, is that the problem? Maybe that wasn't the problem. That bothers me. This is too big. So we got to get those subscript. But see, this here, did you think that was a sulfur or something? No. You thought that was solid. Okay, so there's no charge. There's no charge. It had a plus 2 charge and now there's no charge. How in the world does that happen? It gained electrons. Had a plus 2 charge. Now there's no charge. It had to get some negative charge. Gained electrons. Right? So that is a reduction. And so that must be the oxidizing agent. Right? The species that was reduced is the oxidizing agent. Let's try another one. Which species gets oxidized in the following reaction? Did you get it? Not a single soul got neighbor help, I could tell. You know how I could tell? Nobody was talking. Is everybody self-confident? Okay, so is the answer D as in boy? D as in dog. Is that what you guys thought? Anybody want to go over it? Raise your hand. Okay, so the question is, which species gets oxidized? So this one wasn't asking what's the oxidizing agent. It's just wondering who's getting oxidized. Well, is this one getting oxidized? This one has a plus charge, and now it has no plus charge. How did it lose its plus charge? It gained an electron. Reduction is gaining of electrons. So that's not oxidized. That species was reduced. Was this species oxidized? First of all, I don't even have to look over there. Don't look. Because I have to know it had to have been. How do I know? Because if this species was reduced, that's the only thing over that could be oxidized, right? So that's one way I could know. Second of all, I can look and see that there's no charge here, and then there's a +2 charge. Does that mean gained electrons or lost electrons? Lost electrons. Oxidation is loss of electrons. Yeah? Okay, I think the reason is because what they're talking about, what's being reduced, is this number. See how it's getting smaller as you gain electrons? I think that's where the term reduction comes from. The term oxidation comes from early on. They realized, wow, anything that interacts with oxygen changes some weird way. And so it's too bad that they didn't choose two words that kind of were opposite of each other, more in terms of vocabulary or the Latin roots. So that's kind of a problem to me. This should have been reduction, and maybe going back this way would be like augmentation or increasing or something like that. I don't know. But yeah, this is the words. Sorry. I'm sure they're not the words Heavenly Father would have chosen. He's got some other names for it, but that's what we got. Okay, so here's a little bit of a complex one. You want to try to get this one? Talk to your neighbors so that you can get some help. Oh, you got it? Already? Wow, that's fast.
I might be wrong.
Huh?
I could be wrong.
Yeah, that's always possible. To everybody.
Potentially mistake.
But I haven't been wrong for at least 3 minutes, so I might be able to help. I think that's right. Oh, look, all three of you guys got that. Oh, no, she didn't get it. You might. Okay, you're still thinking. Did you guys agree?
Yeah.
Yeah?
Is that it?
You have no clue, or are you just guessing? Or what do you mean?
Because there's no charge over here, which means it's getting.
Okay, so what do you know about this? What would it have been an easy question if they would have asked you? I agree that it's hard to tell what's going on here, huh? What about manganese? Can you tell what happened to manganese?
It lost two.
It lost 2 electrons?
Wait. Two means.
What are there more of in this thing? Protons or electrons?
I don't know.
How many protons are in manganese?
25.
25. How many electrons?
25.
25. So what is there more of? Protons or electrons?
That's equal.
They're the same. That's right. What about here? What are there more of? Protons or electrons?
There are protons.
There's more protons. There's fewer electrons, right? So here, there was the same, and now there's fewer. So this species has done what? Gained or lost electrons?
Lost.
Lost. What do you call it when you lose electrons? Oxidation. Very good. So manganese was oxidized. Is that what you just decided?
Yes?
All right. Do you agree with that, or did I put that into your head?
No, I agree with it.
Okay, so manganese was oxidized. What does that make it in terms of agent-wise? Is it the oxidizing agent if it's oxidized? If this was oxidized, what does it mean this was? What happened to this thing? It was reduced. Who reduced this? The manganese did it. The manganese was the reducing agent. The thing that was oxidized is the reducing agent. This one was reduced. It must have been the oxidizing agent. Right? Any luck? It's A?
Is that a proud laughter or a nervous laughter?
Because age.
Explain to me how you know that. Explain to me how you know.
So because age is gaining electrons here, and Mn is reduced.
Oh
Yeah.
yeah.
Is manganese is being reduced? Are you confident of that? How can you tell? Tell me how you know it's being
So
reduced.
here it's the normal is
Zero.
Here it's plus
All right.
2. Loses 2 electrons.
That plus 2 means it loses 2 electrons?
Yeah.
Okay, so what's your mnemonic device? Oil. That's for loses. What is loses? Oxidation is loss. Oxidation is loss.
So is there like
Okay, let's do this as a group. I think everybody's okay. Yeah, go ahead.
equation like that? The oxidation can be at the same time the oxidize?
No. If you're the oxidizing agent,
You oxidize someone else.
you oxidize someone else. Therefore, you must have been reduced yourself.
Well, oxidation.
Yeah, that's not a good thing to dwell on. It'll drive you crazy. All right. Here it is. Oh, sorry. Taking the equation here and looking at the easy parts. What's the easy parts? Yeah, but I mean, this one looks really easy to me. Does that look really easy to anybody else? Because we go from 0 to plus 2. Right? Now, some of us still are struggling with that, but we'll get there. And I think that if we sit there long enough, like what is there more of in this thing? Electrons or protons? They're the same. That's why there's no charge. What about here? What is there more of? Protons. So that means we must have gone from here to here. We must have done what with our electrons? Lose 2. We lost 2 electrons. Oxidized. Oxidation is loss. Let me introduce to you this other mnemonic device. Leo says grr, because Leo is a lion. Leo says grr. Did you know the Samaritans? You know who the Samaritans are? They kind of moved away from the Jews. They were not very happy with that sort of thing, and they tried to use their own gods, and they started worshiping their own gods. But there were so many lions in the land, and the lions started attacking them and killing a lot of them. And they got really upset with this. And like, how are we going to keep the lions from killing us? And so they went to the Jewish people and said, do you have any prophets that could teach us about your God? Because you guys don't get attacked by lions nearly as much as we do. And so there were a couple of prophets that left the Jews and went to teach the Samaritans. And that was offensive to the Jews because they were like, you're just leaving to go teach these sinners. Why would you not just stay here and do what's right instead of going living with those sinners, right? Because they had this idea that if you lived with a sinner, you were a sinner type thing. So they had these lion prophets. Pretty interesting scenario. They were looked down upon because they went. And they didn't adopt Jehovah as their only God. They just added him to the repertoire. But I think it did decrease the amount of lion attacks that there were. Anyways, Leo says grr. Leo stands for loss of electrons, oxidation. Grr stands for gain of electrons,